Hello everyone, and welcome to Algebra 2, Lesson 6-7, Investigating Graphs of Polynomial Functions. This is part 1 of this video. We're going to be investigating end behavior and the general shapes of graphs. So first, let's look at the different types of graphs we can have and what they can look like. I have here a display of the different types of polynomials that we have and a general idea of what their graphs could look like. So a linear function, which is degree 1, will look like a line. Quadratic functions, which are degree 2, will look like a parabola. Cubic functions, or degree 3, have this lovely N shape. Quartic functions, which are degree 4, have this lovely W shape. And quintic functions, which are degree 5, have this lovely shape like this. Please note that the number of minimum and maximum values is generally going to be one less than the degree. So this is degree 5, and this has 4 minimum and maximum values. This is degree 4, it has 3. Degree 3 will have 2. Degree 2 will have 1. This won't have any minimum and maximum values. Okay, another thing to note is that for a degree 3, it could also look a little linear. For a degree 5, it can also look cubic. So for a degree 5, this is the most number of maximum minimum points, but sometimes it looks a little cubic. So you have to be careful with that, but this just does give you an idea of the general shape of a graph, and sometimes it'll look like something that's less than its degree. We're going to investigate now what we call end behavior. So let's look at what that is, and then we'll talk about how to determine it just by looking at a polynomial. End behavior describes the value of the function as x gets very large, approaching positive infinity, and very small as it approaches negative infinity. So basically, it's what the function does at the end. So it's the behavior of the function towards the ends, all the way to the right side and all the way to the left side. And what we do is we use these lovely math symbol sentences to describe what's going on. This says, as x approaches positive infinity, this means on the right side of the function, where is this arrow pointing? Is it pointing up or is it pointing down? If it's pointing up, you would say f of x approaches positive infinity. If it points down, you'd say negative infinity. And then the next symbol sentence says, as x approaches negative infinity. This means on the left side, where is the arrow pointing? And our arrow is pointing down in this example, so f of x is approaching negative infinity. Notice in this one, this is our graph. As x approaches positive infinity, so what's it doing on the right side? Well, it's pointing up. F of x is approaching positive infinity. And then as x approaches negative infinity, we're saying, what is it doing on the left side? F of x is approaching positive infinity. It's pointing up. Okay, so it's saying you always investigate the left side and the right side, and then you always say where they're pointing. If they're pointing up, you use a positive infinity. If they're pointing down, you use a negative infinity. Now, you don't always need a graph in order to tell you about this. So let's go back. I'm going to go back a slide, and let's take a look at a pattern that shows up. If you look at the degrees, and then you look at the arrows for the end behavior, notice degree 1, one side points up and the other side points down. The same thing is true with degree 3, up and down, and the same thing is true with degree 5, up and down. So if it has an odd degree, they're pointing in opposite directions. And then look at degree 2 and degree 4. They have even degrees, and they're both pointing in the same direction, up here and up here. So that's a good clue as to what's going on with our end behavior. The degree can tell us what's going to happen a little bit. And then we also have one other thing to look at. So let's look at those rules for telling end behavior. Whenever I'm writing end behavior, I always start off by writing this lovely symbol sentence. It always starts the same way. As x approaches positive infinity, f of x approaches some sort of infinity. And I just have to fill in this blank with a sign. And then I say, and as x approaches negative infinity, f of x approaches, again, some kind of infinity. And I have to fill in this blank with a sign. So these sentences always look exactly the same. You're always looking as x approaches positive infinity and as x approaches negative infinity. And then you just have to decide on the signs. And to tell the signs, it's all about the leading term. So once it's in standard form, you look at that leading term. The sign of the leading term will tell you the sign that belongs in this first sentence, what's happening as x approaches positive infinity. So if this sign is a positive, then this will be positive. If the leading term is negative, then you'll have a negative over here. Then the degree will tell you about the other symbol that I have to fill in. If it's an even degree, this sign right here will match this sign right here. So if you said positive for the first sign, it's going to be positive for the second sign. If the degree is odd, then the signs are opposites. So if you said positive for the first sign, this sign is going to be negative. So for example, I have this lovely function right here, and I notice my leading term is 6x cubed. It's positive, and the degree is odd. So when I wrote my symbol sentences, I put a plus sign here because the sign was positive. And then I put a minus sign here because the degree was odd. So positive here, negative here. So you're going to try it with an example. In example 1, I asked you to identify the leading coefficient, degree, and end behavior for both of these functions. So pause your video, identify those things, and then hit play to see if you're right. In part A, my leading coefficient is -4 because it's already in standard form. I can just take that first number and say that that's my leading coefficient. The sign on that is negative, which is important, and the degree is odd. So when I wrote my symbol sentences, I said as x approaches positive infinity, f of x approaches negative infinity, because this had to match the sign for my leading coefficient. And then I said as x approaches negative infinity, f of x approaches positive infinity, because my degree was odd. So these signs right here don't match. I said negative the first time, so I have to say positive for the second sentence. In part B, my leading coefficient was 1. So the sign on that is positive, and the degree of this leading term was even. It was 6. So in my end behavior, I said as x approaches positive infinity, f of x approaches positive infinity, because my sign was positive, so this is positive. And I said as x approaches negative infinity, f of x approaches positive infinity, because my degree was even. So this sign that I answered the first time is the same sign I need in my second sentence. Okay, so we've gone over end behavior. Now let's look at a graph and determine the degree, whether it's even or odd, and whether the leading coefficient was positive or negative. So this is example 2. Again, you're telling if we have an odd or even degree, and you can tell that by how the arrows are pointing. And then we're also going to tell whether it's a positive or negative leading coefficient. And to do that, you're going to look at the right side of this graph, and that's going to give you the hint that you need. Think through how we determine end behavior. In part A, this is an odd degree because the arrows point in opposite directions. And it's also positive because the arrow on the right is pointing up. So that's what tells us. We tell odd because of the opposite directions, and the arrow on the right points up, so it's positive. In part B, it has even degree because the arrows are pointing in the same direction. And our leading coefficient is negative because the arrow on the right is pointing down. Okay, and that's what our end behavior tells us. because the positive or negative affects the x going to positive infinity. And so that's the arrow on the right. So that's everything about end behavior. Make sure to watch the other videos for this lesson.